Welcome to Mrs. Elwood's Physics. Yesterday, we worked through some inelastic and elastic collision examples. And so our homework was question 2 on page 9, an inelastic collision example. We had a bullet being shot into a block of wood, and afterwards they were stuck together, which makes this an inelastic collision. Yesterday, together, we set up the problem. We used our inelastic collisions equation to get that set up, and then we plugged in our numbers. So today, what we need to do, or what we did last night for homework, was we solved through it, and I'm going to walk you through that for anyone who needs it. The final answer will be displayed when I'm done walking through it. So if you've got all of your work done, then you could jump ahead a little bit in this video to just see the final product. All right, so first thing we would need to do is simplify our problem. So on the right side, we are going to have 0.05 kilograms times that velocity that we're looking for, plus 10 times 0 gives us a big ol' whopping 0. On the right side, we're going to have 2 meters per second, and that is being multiplied by 10.05 kilograms. Okay, that's just 0.05 plus 10. Then on the right side, we can simplify that further, multiply those two together, and we get 20.1 kilograms times meters per second. And on the left side, we can get rid of that 0, and we are left with 0.05 kilograms times velocity initial. All right, then we're going to go ahead and we're going to divide by 0.05 kilograms. And we will end up, I'll put my answer off to the side since I ran out of room. We'll end up with an answer of 402 meters per second equals that initial velocity of the bullet. All right, there you go. Then the next thing it asks is, what is the change in velocity for that bullet? Right, and we remember our change in velocity equation is velocity final minus velocity initial. And we're going to do that for the bullet and for the wooden cart. Okay. So then the bullet, that's what we just calculated, right? That was its initial velocity. Both of them had shared the same final velocity, right? 2 meters per second. So we're going to say final velocity is 2 meters per second minus the initial velocity, 402 meters per second. And so that the change in velocity for the bullet ends up being negative 400 meters per second. That's a large change in velocity. But remember, it's a very small object. The block of wood shared that same final velocity because it was an inelastic collision. However, it started at rest. And so since the block of wood was many, many, many times more massive than the bullet, we would expect a much smaller change in velocity. And guess what? We see only 2 meters per second, which is a much smaller change. And so that's how we know this is realistic. The tiny bullet has a huge change in velocity. The large block of wood has a small change in velocity. And there we're looking at the absolute value. We're kind of ignoring the fact that this is a negative sign, absolute value, when we're comparing. All right. So that was your homework from last night.